All right, for section 2.2, the graph of a function. We're going to look at some graphs and we're going to determine whether or not they're functions. And I think we have two specific objectives for the day. Yep, identify the graph of a function and then obtain information from or about the graph of a function. Okay, so first things first, guys, to identify the graph of a function. If we are trying to determine whether or not a picture on a graph is a function, the easiest way to do that, if we have a picture, is to use what we call the vertical line test. Okay, so the vertical line test just tells me this. If I have a picture to look at, maybe that's something like this. The vertical line test just says, okay, if I draw a vertical line, no matter where I draw a vertical line, okay, so maybe I'll draw one right here. Okay, if I draw a vertical line anywhere on the graph, it should only touch the graph in one place if the graph is a function. Okay, so this one would be a function. However, if I have a graph that looks like this, then we have, here's my vertical line, right? Then we have two places where the vertical line hits the graph. If that happens, we are not dealing with a function. This is not a function. Okay, so the vertical line test is a really simple way of, if you have a picture, determining whether or not you're dealing with a function. So example 1 just has us identify if a graph is a function. So here the vertical line test works. This is a function. Same thing here. Any vertical line you draw, no matter where you draw it, right, it only hits the graph in one place. All right, so A and B are both functions. Looking at C and D, however, notice we have two places where that line hits. Okay, and they've marked them for us here. And you know, if you do another one here, two places where it hits. So if it hits the picture in two places, if there's anywhere where you can draw a vertical line and it hits it in two places, then we're not dealing with a function. So those are non-examples. Okay, so that's the vertical line test. That should be a review. Objective 2 says we're going to obtain information from or about the graph of the function now. Okay, so some of the things in your homework are going to be this long, where we have A, B, C, D, E, F, G. But you know, it's not going to be too terrible. So let me just go through with you one of these and show you how easy it is. Should be pretty simple. So for part A, it says what are f of 0, f of pi over 4, and f of 7 pi over 4. What this is saying is these are x values, right? So what is the function evaluated at 0? So if we look at 0, f of 0, it's just going to be the y value. The y value is the evaluation. So f of 0 would be 0. F of pi over 4 gives us a y value of 2. Okay, and then f of 7 pi over 4 gives us the y value of negative 2. Okay, so whenever you're evaluating a function at a specific place, it's going to be the y value that comes out. Then for B, it says, what is the domain of f? Okay, so f, again, is just the function, right? So it's just this picture. So it's the picture that we have graphed. It's this picture that you see. And the domain of that, since it ends here and starts here, the domain again means x values. So the x values from here to here are 0 to 2 pi. All right, and they include 0 and 2 pi. So in interval notation, we include 0, 2 pi, and we use brackets to show that they're inclusive. All right, the range is the y values. So the y values never go below negative 2 and never go above positive 2. So the range is going to be inclusive of, I believe, because we include negative 2, 2. Okay, then it says to list the intercepts. So these are just going to be the points where we have intercepts. Okay, so let's look at these points here. So an intercept is just a place where it crosses an axis, right? So we'll do these in green, even though they're already in black. It's going to be these 5 places. So 0, 0 is 1, pi over 2, 0 is 1, pi, 0 is 1, 3 pi over 2, 0 is 1, and 2 pi, 0. Okay, those would be the intercepts. And then it says, how many times does the line y equals -1 intersect the graph? All right, so let me erase a little bit here. Okay, let's erase a little bit on the graph so that we can draw that in. Okay, so how many times does the line y equal -1? Okay, y equals -1 would be this line right here. Okay, so what it's asking you is how many times does that intersect the graph? Well, we got 1, 2, 3, 4. So 4 times. And then for f, it says what values of x does f of x equal -2? Okay, so we're looking for x values, x coordinates, where we get a -2 out. The only places that happen are here and here. All right, so 3 pi over 4 and 7 pi over 4 are the two places where we get a -2 out of the function. The only two places where there's a -2 in the y. Okay, then for g it says, for what values of x is f of x greater than 0? Okay, so basically what x values give us a result that is bigger than 0. So from here to here we're bigger than 0, and from here to here we're bigger than 0. So to show that, what we'll say is, we'll say inclusive 0 to pi over 2, okay, which is right here. And then we have, I guess we can do a union between these. I don't know if they'll make you use the union. But then the other place that we have it is from pi to 3 pi over 2, inclusive. Oh, but it says greater than 0. Oh, my bad. So greater than 0 means that we don't include it, because if it was greater than or equal to 0, then we would include it, right? So these are actually parentheses. My bad. We don't include them. I should have read that again, because we're just looking for places that are greater than 0, not equal to 0. Okay, so these are not brackets, these are parentheses. All right, so that's that one. And then I think there's a bunch of slides that just do the same thing I was just doing. And then it says here, this will be the last one that we do, I think. Example 3, obtain information about the graph of the function. Okay, so now instead of a picture, they give us an algebra problem. Okay, so we're going to use algebra to figure this out. So for the domain of this function, remember the domain is just the possible x values. I can plug whatever x value I want in here. The only one that I can't plug in is what makes this go to 0. So that would be -4, right? So it's the x values where x cannot equal -4. That is the domain. Then for b it says, is the point 1, 3/4 on the graph? All right, so we can check that very simply. 1 is an x value. So if I plug a 1 into the function, do I get 3/4 out? So is 1 plus 3 over 1 plus 4 equal to 3/4? And the answer to that is no, it is not. It's equal to 4/5. So we would say no. Okay, it's not on the graph. Then it says if x equals 2, what is f of x? All right, so we're just going to solve, right? We're just going to solve when x equals 2. So that would be 2 plus 3 over 2 plus 4, which is 5/6. And then it says what point is on the graph of f? Well, we plugged a 2 in. We got a 5/6 out. So that is a point on our graph. Okay, then we have part D here. What happens if we have f of x equal to 4? Then what is the x value? So notice in part C, we said, okay, what happens if x equals 2? So we plug the 2 in for x. Here we're saying what happens if f of x equals 4? So we're going to replace the f of x with 4. So we're going to say 4 is equal to x plus 3 over x plus 4. Okay, to solve this, I'm going to multiply both sides by x plus 4. Right, so I have 4x plus 16 equal to x plus 3. Then I'm going to move all my x's to one side, so I have 5x is equal to, I'm going to subtract 16 from both sides, and I get -13, I believe. Okay, then divide both sides by 5, I get x is equal to not 5. Okay, back to this, we'll do this in red. X is equal to -13 over 5. Okay, so if I plug in a -13 over 5, I'll do this in blue. -13/5, 4 is a coordinate. Okay, and then for E, it says, what are the x-intercepts of the graph of f, if any? All right, so x-intercepts happen when y values are 0. All right, so what happens if the f of x goes to 0? I have 0 is equal to x plus 3 over x plus 4. Multiply both sides by x plus 4, I get 0 is equal to x plus 3. So then x is equal to negative 3. So we have an intercept at negative 3. All right, and then I think it goes through all these examples. We can double check our answers. Yes, we got that. Good, we got that. X equals negative 3. Okay, oh, there is one more. It's example 4. Okay, so for the last one, you guys, and then you guys are on your own for this. Example 4 talks about the average cost function. So the average cost C per drone of manufacturing X drones per day is given by this function. All right, so this is the manufacturing function of drones manufactured per day. It says determine the average cost of manufacturing 10 drones, 20 drones, 30 drones, etc. Okay, so a couple things that we could do here, guys. The easiest thing would be to plug this into Desmos and then find out what happens if we put in 10 in for x, which would just be the line, right? X equals 10. But if we wanted to do this algebraically, we're just going to plug that 10 in for x. Okay, so I'm gonna kind of use a little bit of a cheat here for the sake of time. What they're doing here is they're just taking this formula that's given, right? They're taking the function and they're plugging a 10 in for it. So they plugged a 10 in for all of the x's. And then when you do that out, just remember you have to solve your exponent first, right? And then multiplication and division, and then from left to right you add. You should be getting this number out. So make sure that you can do that. And then for B, we plug a 20 in because it says for B, how much does it cost for 20, right? So then 20 gets plugged in, and then we get this guy. So now it's getting cheaper as we manufacture more per drone. Okay, then you plug a 30 in, and you get this guy. Okay, then it says for D that they want us to graph the function between 0 and 60. So basically, we want to just look at the picture from 0 to 60. So you can go ahead and graph that, and then when you graph it, just make sure to set your x's to be between 0 and 60. If you're on Desmos, you could just look at this. You know, you could set it as well on Desmos. I don't know if you guys know how to do that, but on Desmos you can. I guess I can show you really quick on Desmos if you're graphing this. Let's see if this thing will load. You can hit this little toolbar in the upper right, and you can set your x-axis and your y-axis to whatever you want. All right, so if you wanted to look at 0 to 60, then you could set your x-axis to be between 0 and 60, and it'll adjust your graph that way. All right, so let me go back here. Okay, so the last thing is, oh, they want you to be able to do a table. I don't know that I'm going to have you do a table in your homework, so don't worry about the table too much. But do be able to graph that function in Desmos. You can also try it on your graphers, your TIs, and just adjust your table so that you're looking at 0 to 60 on your x-axis. And I can help you guys with that in class 2 next time if that's a struggle. So that's it, guys. That is 2.2. I'll catch up with you guys next time. You're working on 2.2 homework on My Math Lab. All right, take